Hello everyone, this is tutorial 10 of Math 2000. Today I have 3 questions to go over with you, so let's begin. Question 1. Let S be a bounded subset of R2. 1a. If R is a rectangle as defined here, and this rectangle has a property that R intersect S is the empty set, then show for every epsilon greater than 0, there's a subrectangle R epsilon contained in R such that R epsilon intersects the closure of S is equal to the empty set, and the difference in the areas is less than epsilon. So to do this question, I will first pull out a technical lemma, and this technical lemma is as follows. R complement closure intersect the interior of R is equal to the empty set. And if you've forgotten what closures and interiors and that type of stuff are, you could check lectures 3 and 6 from fall 2021. So for closure and interior, check your old lectures. Okay, and I'll prove this lemma too. So to prove the lemma, we begin by picking something in the closure of the complement. And if you're inside the closure of the complement, there exists a sequence there exists a sequence from our complement such that the limit of this sequence gives back your point x. That's what it means to be in the closure. So that comes from lecture 6 specifically. Then we now suppose that x is inside the interior of R. So the definition of interior, which is from lecture 3, so suppose x is in the interior, there exists a radius greater than 0 such that the ball of radius r around x is contained by R. Since from above we have xn converging to x, then there exists some xn which will be very close to x. So if you're very close to x, your distance to x will be less than r. And if your distance is less than r, then you'll be inside the ball. So there exists some xn that's really close to x. So close that xn is inside the ball of radius r around x, and that's contained by R. But we also know that the xn's, they come from R complement. So that's an obvious contradiction. We're saying xn comes from R and R complement. There is no such thing. So therefore, contradiction. Therefore, we conclude that R complement closure intersect R interior is equal to the empty set. And that's the end of the lemma.